Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to improve our math skill. Today is our day number 33. If you want to watch any of the older videos, just type in this tag Keshwani Prep Math and then day, whatever day it is. You have to put in math because I make other videos which are for vocabulary, where you would simply put in vocab. So you simply put in vocab dash day 33 and you can learn all the words on day 33 that we covered for vocabulary. Today is our day 33 of the math. Here's the question. Let me put down the question on the blackboard first. We are told that the digits of a two-digit number are reversed. And as a result, the new number, let me switch the marker, this thing is not quite dark. We are told that the new number, or new integer, whatever you like, new number that is obtained differs from the original by 18. In other words, their difference is 18 between the integer that you started out with, and then we reverse the digits, and as a result the difference between the two numbers, the original number and the new number that we created by reversing the digits, the difference between the two is 18. We are not told which one is greater, whether the original number was greater, it doesn't matter, the difference is 18. The question simply is, by how much do the two digits differ? By how much do the two digits differ? For example, if the original number was 93, if you reverse the digit it becomes 39. Whatever their difference is, obviously their difference is not 18. We have a difference of 18 here. So obviously that is not the integer that we're talking about. But the question here is, how much do the two digits differ? For example, in this case, the two digits 9 and 3, they differ by 6. That's the question here. How much do the two digits differ? It's an algebra question. There is nothing tricky about it. It's a straightforward algebra question. I'm doing it here because a lot of the times I have seen students having trouble with something like this. It's particularly the setting up the problem. Not particularly, actually that is the only problem. If you know how to set up the equation, the rest is downhill. The rest is very straightforward. What I want you to do right now is pause the video, try to solve it yourself, or better yet, don't try to solve it yourself, solve it yourself. Once you have the solution, I want you to resume the video, but do not continue watching the video. Try solving it yourself first. See what happens, okay? I'll give you a few seconds to pause and unpause. There we go. The pause and unpause constitute the pausing and the unpausing constitute 3 sips of my tea. So here we go. How do we express this number? Let's pretend it's 93. Let's pretend it's 93. Somehow we have to express this 93 in algebraic language. Well, that 93 is same as 90 plus a 3. Now how do I represent 90 in the language of the algebra? Let's pretend that my 10 digit is A and my unit digit is B. If the 10 digit is A, how do you express 90? Well, 90 would be expressed, your 10 digit is A. A represents 9, B represents 3, the unit digit. How do I write 90? 90 would be 10 times A, because that's what it is. When you write 53, when we write 53, of course we all know that that 5 is not a 5, that 5 is a 50, because it's in the 10 digit. That 5 represents 50. 50 plus the 3. So how do I represent that 5? If I had called this X and Y, if I call the unit digit Y and the 10 digit X, in this case, the 10 digit is expressed as 10X, because X is 5, 10 times 5 would be 50, plus my Y. Voila, there you go. This is the expression of this number 53 in terms of X and Y. Right here, this is the expression. This is how we express this number in the algebraic language, where X happens to be 5 and Y happens to be 3. 53. This represents 53. The same thing is going to go on here. 10 times A, or A is 9. 10 times excuse me, and now my cup is getting empty. 10 times A, since A is 9, 10 times 9 would be 90. That's your this part. 10A plus the B. That's all it is. So that is now how you would express your number, 10A plus B. Now what happens when you reverse the digits? Well, when you reverse the digits, nothing happens. It's just the opposite. Instead of X and Y, your number, instead of 53, your number now becomes 35. And 3 is your X, 3 is your Y, the unit digit, so this is your Y. And 5 is your X here. That doesn't change. 5 still is represented by X, because that's what it is. It's a language. Just because you switch it, we cannot continue calling this first one X, because X represents 5. 5 used to be in the 10 digit. Now the 5, when we switch it, becomes in the unit digit. So now it is YX. But it is not Y times X, you understand? We are expressing our integers with the symbol X and Y. So when you say YX, do not read this thing as Y times X. That's not what this is. Just like this one, when I write down like this, what is this? That's not 3 times 5, it's 35. It is 30 plus a 5. That's how we represent our integer. And we are simply calling our 3, we're simply calling it Y, we're calling our 5 X. That's what it is. We're giving them names. You have to give them name in algebra. That's what algebra is. It's an expression of mathematical concept. In a written format is called algebra. Whoever the guy who invented it, some Arab guy by the name of Algebra. He was the one who came up with the notion of expressing this mathematical concept with the algebraic notation in a new language where we can express these concepts like 53 with X and Y. And of course you have to define, you have to tell the world that X represents my, in this case, in the case of 53, you would say that X represents my 10 digit and Y represents my unit digit. If it were 35, in this case, you would have to tell the world that your X represents the unit digit and Y represents the 10 digit. Because X, basically what you're telling the people is that X equals 5, Y equals 3. Well, that's what it is. So now it becomes this. So when we reverse it, it becomes 10 times Y plus X. You see, 10 times Y, because Y is your 3. 10 times Y, which is 3, plus your X, which is 5, which gives you the 35 that you're looking for. Here you have 10 times X plus a Y. Same thing here. If you were to reverse the digits, let's use it in a different color. Let's talk about 93. If you were to reverse the 93, it becomes 39. And your A equals 9, so that's what this is. And your B equals 3. That does not change, obviously. It can't change, otherwise you won't be able to reverse it. So now here, what we have here is 3 tenths plus a 9. 3 tenths plus a 9. But 3 is represented by B. So B times 10 plus a 9. b times 10 is written as 10b plus a 9. Voila, you see, it's been reversed. From this red box to the blue box, the digits have been reversed. And we are told that when we do that, the difference between the original integer, which is 10a plus b, and the new integer, which is 10b minus 9, in this case, of course, where the hell does 9 come from? 9 is our a. Because we're not dealing with 9, obviously, that's the whole point. We do not know what these a and b's are. So our original integer, which is 10a plus b, minus the new integer that we created by reversing the digits, which is 10b plus a, the difference between the two integers is 18. And if you understand that part, the rest is downhill. So let's do it then. So our original integer, which was 10a plus b, minus our new integers, which is 10b plus a, equals 18. Now where does this 18 come from? Where does this 18 comes from? Where does this 18 come from? It comes from this 18 comes from this fact we are told here, right here. I'm not going to erase this part, I want to leave it in the blackboard, that's why I did the demarcation here. The word that I used just now was demarcation, and I shouldn't have used the word because now I have to go to the other room to find out which day we learned this word on. So give me a second. And when I say a second, by now, for those of you who have watched my videos before on a regular basis, know that when I say a second, I am in fact lying. It usually means 5 to 10 seconds, but I'll be right back. Demarcation was the word, which means to set a boundary, to put an outline, to put a border. Demarcate. Deduce, dogmatic, doughty, dubious, divulge. Demarcate, there you go, day number 12. So if you want to learn this word, demarcation, just go to Keshwani Prep-vocab-day 12 and you will learn that word along with all the other words that we learned on that day. I don't know what other words we learned on that day. But anyway, so that's why I put a demarcation here, the boundary, the border to separate the two things, because I don't want to erase this thing. Anyway, enough of the talk. So 10a minus 10a plus b, 10a plus b, this is our original number. Original, how do you spell original? Original number, and this is our new number that we created by reversing the digits. 10a plus b minus minus 10b plus a equals 18. Open the parenthesis. 10a plus b minus 10b. This minus is distributed with this guy and with this guy. Minus a equals 18. As you can see, the rest is very straightforward, very simple, nothing to it. So we have a 10a and we have minus a, that gives us 9a. And then we have 10b, a negative 10b right here, and a b, which gives us minus 9b. And the whole thing we are told equals 18. You got a 9 here, a 9 here, and 18 there. Let's divide the entire equation by 9. If you divide the whole equation by 9, what we find is that a minus b equals a 2. a minus b equals 2. The question was, what's the difference between the two digits? We just found out by how much do the two digits differ. By how much do the two digits differ? The two digits a minus b, let's not put way out there. The difference between a minus b we just learned is 2. Voila, that's it. That's it. Whatever these two digits are, their difference is 2. Now we know for a fact. Now in case you're curious, how many such integers exist where the difference between the two digits is 2, and when you reverse the digits the difference is 18. Well, how many are there? Well, the two digits is what we have to use here, plus the fact that we cannot use the 0 because you can't have a, if you can't go around saying 0 and 2. Here the difference is 2. Here's the difference is 2, but this is not a 2-digit number. This is a 1-digit number, so 0 doesn't count. So we are using the two digits in our calculation, plus the fact that the 0 doesn't count. That leaves us with 7 different combinations. I'm going to show you the 7 different combinations that exist where the difference between the two digits is 2, and when you reverse the digits, the difference between the original number and the new number is 18. I'm going to show you in a second. But anyway, I need the room, so I need to raise this part. Well, since the difference is 2, let's go in a logical way. It's very important that you go logical and systematic manner. Since the difference is 2, let's start with 1. If the first digit is 1, the second digit has to be 3 because the difference between the two digits is 2. And since we're talking about a difference of 18, I'm going to put the reverse digit on the top because it makes it easier to see, and you will see that 31 minus 13 is in fact 18. What will be the next pair? The next pair would be, instead of 1 we'll have 2, so we'll have 42. 42 becomes 24, and again when you take that difference you will see the difference is 18. Now instead of 2 let's have a 3. If this is 3 then this will have to be 5. 53 and 35. Let's make the unit digit 4. 4 and 6, which makes difference is 2. Now it's 46. Again, the difference between 64 and 46 is 18. So we have 4. Let's try 5 on the unit digit. If unit digit is 5, 10 digit would have to be 75. 75 and 57. Let's make unit digit 6. 86 and 68. And finally, let's make unit digit 7. 97 and 79. Voila. There are 7 such possibilities, but of course we were not asked what that original integer is because it wouldn't be possible for anybody to ask, because if you ask me what was that original integer, my answer would be, how the hell do I know? There are 7 possibilities here. Therefore we are not asked what that original integer was that the person was manipulating. The question simply was, what is the difference between the two digits? Which of course we can answer. The difference between the two digits is 2. It doesn't matter which pair we talk about, that's what it is. There are 7 possible pairs. Anyway, that was the end of it. I hope you found it helpful. I hope you got something out of it. But that's what it is. You have to be systematic and logical, and don't freak out. Be calm and set up the equation properly, because that is the most important hurdle. The rest, as I said already many times, the rest is downhill. Setting up the equation is the most important part in any algebraic problem. Do you understand? If you wish to get hold of me for personal private tutoring, I do face-to-face tutoring, of course, in person in Connecticut and New York area. I also tutor over the internet via Skype for SAT, GRE, GMAT and TOEFL. You can go to any of these website addresses and send me an email, or you can go to kashwaniprep.com and send me an email from there. Alright? Thanks.